Emile, as the futurist of the panel, where do you think we sit, almost more than a decade from now in this industry in terms of what cell chemistries are going to look like?
Oh boy, well again, I'm certainly not going to sit here and try to predict the future, but I'll tell you what we're working on and why. Pure Lithium is taking the approach, the lithium metal battery, couldn't agree with Dean more. It literally is the holy grail. And Ken, to your point about pack innovation, that's only going to supersize lithium metal because those are learnings that will then transfer over to lithium metal packs when we get them in a vehicle one day. The approach that we're taking at Pure Lithium is the absolute cheapest battery, period. We have to take the cost out of it, and to enable mass adoption of vehicles, we want the 2- and 3-wheel market in India. We want the battery everywhere. So as my co-founder, Professor Don Sadoway of MIT will say, make it out of dirt, preferably local dirt. And that literally is the foundation of everything we've done in the last 2.5 years at Pure Lithium. So we're taking the cost out of the lithium metal by using an aqueous dilute source of brine. We can make a great, beautiful 5-micron battery electrode covered by a polymer membrane that we then put in a battery. And we're pairing our batteries with cathodes that do not contain lithium. That sounds completely crazy, but if you think logically about it for a moment, the cathodes we use today are optimized for lithium ion. The lithium is all in those cathodes, and it moves over into a graphite host that contains no lithium. So think of a paradigm shift for a moment. You have lithium metal on the negative side. Why do you need lithium on the positive side? You actually don't. So we work with vanadium, which was introduced to the world to pair with lithium metal by Nobel Prize winner Stan Whittingham. It doesn't contain lithium, and we can get the energy density at NMC without the price inputs. So vanadium is the 5th most abundant metal, transition metal in the Earth's crust. A lot more of it would need to come online, and that's going to be capital intense. But at the moment, what we need to do is prove that we can have a lithium metal cell that works, that an EV manufacturer would actually adopt, and that's the path that we're trying to pursue with Pure Lithium. Will that actually happen in 2030? We are trying our absolutely hardest to. We think we're on a rational path, but who knows? Science is very, very difficult, and batteries are very difficult, which is why we've seen 2 chemistries commercialized past gigawatt scale in our lifetimes, lead acid and lithium ion. We're hoping lithium metal will supplant lithium ion. It's what the Nobel laureates were thinking back in the early 70s. And let's see if today's technology, characterization, companies like Dean's and myself and Albemarle can actually make it happen. But I do think lithium is here to stay.
Emile, you've come up with beautiful in terms of lithium metal interaction. How do you do that?
Well, so, it wasn't me. It was Professor Don Sadoway. He invented this very special block copolymer back in the 90s with a professor named Ann Mays, and it was compatible with lithium metal, which was one of the beautiful things about it. He cycled it against vanadium, took it to Weatherford, showed it to Albemarle, and it was simply too early for anyone to wrap their heads around this back in the early 90s. So that face is compatible. We have a solid polymer that is completely compatible with lithium metal, and that's really hard to do. It's also hydrophobic, which took us a 1.5 years to make happen. So we can use it to extract the lithium as well. But to Dean's point, I started making batteries using a lithium ion electrolyte. You cannot pair a lithium ion electrolyte with lithium metal. It will eat all of the lithium. And anybody who tells you otherwise is just blowing smoke up into the air because it doesn't work. You had the pleasure of meeting Dr. Shirley Meng. I mean, this is just very well established in the industry. So it's a big challenge to even come up with something that you can put against lithium metal and cycle it that it's compatible with. And we're not going to have an all-solid battery. We will definitely have some liquid on the other side, but it'll be a small amount just to help the lithium get to the backside of the vanadium, a tiny little bit amount, and it's something that I can't disclose, but it's not a flammable organic. So I also just don't see a solid state, I actually don't know of one completely solid state battery company that really doesn't use any liquid at all. But the electrolyte, to Dean's point, is a huge, huge, huge problem. So we're repurposing things that were invented a long time ago and modifying them.
And the cover of The Economist, if anyone hasn't seen lately, is, Can America Build a Battery? Emily, if you're advising, say, the government how not only to catch up to sort of the other best-in-class battery makers, but to surpass them, what should the government be doing?
That's a very difficult question to answer. I think the government, we knew that China was dominating the battery supply chain and the battery space for a very long time. Read the book The Powerhouse by Steve Levine. And we just sat here and slept through it. So we have a lot of catching up to do. And to Diana's point, the IRA does not touch companies like mine, period. If we don't invest in the next generation of technology, if we only invest in 40-year-old technology that we know has supply chain limitations and, frankly, technology limitations to it, we're not going to be able to do anything. So, I'm surprised when I hear people like Jigar Shah talk about we're not going to give DOE loans in mining because we don't know anything about it. Well, maybe that's true, but, how are we going to build a materials infrastructure in the United States if we don't start deploying earlier capital into things like mining and early stage technologies? Because right now as a country, we really don't focus on that. So I would tell the government to really start to examine what you're doing at the bottom of the battery development land and make things a lot easier. And that's why Saudi Arabia is a really interesting place, because they want to deploy very, very quickly. They have no battery infrastructure, nothing. So they're going to build it from the ground up. And it'll be really interesting to see how fast they're able to do it, because they're very serious about it. And they're very excited to throw money at, in ways that our government isn't going to do. So I'd say to our government, we really need to listen to our national labs and put research dollars into the next battery and mining.
Hopefully there are some government folks here in the audience who heard that message and start to actually help out even more. Sorry we didn't get to the silicon anode question that someone asked, but we are a bit over time. I'd like to thank the panelists very much and thank everyone for coming in and listening.